Hi, I'm Yuriko, the web ecosystem consultant at Google.
And I'm Swetha, also a web ecosystem consultant at Google.
We've all seen the flashy demos, the hello world examples that promises seamless AI integrations on websites. But let's be honest, while the hello world examples give us the fancy glimpse of what could be done, they're still prototypes. They don't really show us how AI can actually be integrated in the real world websites. But now, get ready to look beyond the hype because the future of AI and web isn't just theory, it's already happening. Today, we're going to skip the theoreticals and what ifs and get straight to the real deal, checking out actual AI feature examples on the websites and breaking down the tech behind them. In this talk, we will first walk you through the potential ways to implement the AI features to your websites. And we will showcase the real world use cases to inspire what powerful AI features you can build on the web. We will also pull back the curtain and give you an overview of the technical architectures and APIs that enable these amazing real world use cases. Sounds fun? Are you ready? Let's dive in. First, let's recap on the 3 ways you can implement AI features on your websites. So, the first way is using the server-side models like Vertex AI. This is great for running large models for complex use cases or training and retraining models on your data. Then, what many people might not realize is that you also have another arrow in your quiver of AI toolkit. That is, running AI on the client side. The benefit of running AI on the client side is threefold. It's performant, since there's no network dependency. It even works offline. It's private, since everything stays on your device. Your prompt, the data you sent with the prompt, and the response. Last but not least, it's cost efficient. Once the browser downloads the model, running AI is free of cost. You can think of running AI on the server side as cooking in one of those big chef's kitchens. There's a lot of resources like huge countertops and huge refrigerators and many chefs just running around. On the other hand, running AI on the client side is like cooking in your home kitchen. You don't have as vast resources as a chef's kitchen, but it's not costly to implement. You have a basic toolkit and ingredients enough to meet your needs. In addition, the home kitchen is private, so you can do any kind of crazy cooking you want and no one will notice. Now, you might want to use the client-side models for privacy, performance, and cost efficiencies. However, some AI tasks might need to be complemented with the server-side models, and that's where the hybrid approach comes in. One of the reasons for using a hybrid approach is because of the model capability. For example, let's say a user wants to ask a question on an AI chatbot about a service you're providing. With the client-side AI, it might be able to answer the question if the model has sufficient data. However, if the model is not able to provide the answers, then you can fall back to the server side, which can be trained on a more complex and larger dataset. Another reason for using the hybrid approach is the device capability. Let's say you want to make your AI features accessible to everyone on your platform, but your users might be using a variety of devices. In such cases, you might want to decide whether to run the model depending on the environmental factors. For example, if the user is offline but has a cached model on the browser, run AI on the client side. Or if the user is on a low-end device which cannot run any AI on the client side, then fall back to the server side. Later in the talk, we will show how real-world websites utilize the hybrid approaches to make AI inference more efficient, so stay tuned. Now, covering the server side and the client side and the hybrid solution in this talk is a lot. Fortunately, if you're looking for more information on the server side solutions, our Google Cloud colleagues provide many amazing resources. There's a link in the description, so go check them out. For the rest of this talk, we will specifically focus on the two solutions, client side and hybrid. Now, before diving into the real-world examples, you might want to familiarize yourself with the set of technologies that power these examples. First, you got your low-level APIs like WebGPU and WebAssembly, or WASM for short. Second, you got your high-level libraries that wrap these low-level APIs and make your lives 100 times easier to utilize the AI models. These libraries include MediaPipe and Transformers.js. Last but not least, there are some browser built-in models and APIs. These are already set up for you to use out of the box, so all you need is to plug in to a JavaScript API. Chrome has a set of APIs built into the browser called the built-in AI APIs. If you want to learn more, refer to the talk in the description. Now, I will pass the baton over to my amazing colleague Swetha, who will walk you through the real-world examples of websites that implemented seamless AI and achieved critical business impact. Over to you, Swetha.
Thanks, Yuriko. It's very much possible to leverage the strategies we just mentioned in your own website. Let's see how some companies did this. First, let's look at some client-side use cases. Bilibili is an entertainment content platform with over 330 million monthly active users. To make their live video streams more engaging, they created a feature called bullet screen comments, which displays real-time user comments over the video. The challenge Bilibili faced was that the comments can become disruptive if they are rendered on top of the speaker. So they needed a way to know which areas of the screen are the speaker and which ones aren't, so that they could render the comments behind the speaker. Fortunately, this is a well understood problem in the AI field called image segmentation and has out of the box models available. It works by extracting the speaker's outline from the image, enabling developers to know which parts to modify. In Bilibili's case, they could use this model to render user comments behind the speaker. But given that they serve a huge amount of content every day, they needed a solution that was low cost, low latency, and accurate. To achieve this, they used MediaPipe and TensorFlow.js's selfie segmentation model, running fully client-side. And since the model leverages WebAssembly and the device's GPU under the hood, it allows the algorithm to run in real time with very low latency, a critical factor for live video streaming. Thanks to this client-side solution on the web, they were able to improve the viewing experience. In fact, they saw a 30% increase in session duration and 19% higher click-through rate for live streaming videos. Vision Nanny, part of the Google for Startups program in India, is a web platform developed for children with cerebral visual impairment, a leading cause of childhood blindness. It provides AI powered vision stimulation activities such as color identification, counting, hand eye coordination, and more. This is an example of a hand eye coordination activity where the child has to drag the milk to the cat. The best part is these use cases run fully client side, which enables parents and educators to access them anywhere, anytime, such as rural areas or places with poor internet. This also addresses parents' concerns about their children's privacy, as the child's image never leaves the device. They chose to build for the web as it is accessible from a wide variety of devices. Their use cases were powered by MediaPipe's out of the box libraries. This particular example uses MediaPipe's hand landmark detection model, which locates key points of the hands on an image, video frame, or in real time. Another activity they provide uses an audio classification model. In this multisensory activity, children interact with on screen elements using squeaky toys. And they use web GPU when available, allowing the model to run faster. A pilot study with 50 children showed that Vision Nanny's web platform delivered 5 times faster responses, improving dexterity, coordination, and cognitive skills. Therapists also reported saving 3 hours per therapy session by eliminating manual setup of activities. Google Meet has a number of features that are enabled by AI. I'm sure we've been in video calls where there's bad lighting and blurry videos. It's not very ideal, right? Google Meet tackles this with some cool AI features: Studio Lighting and Studio Look to improve video quality. Let's start with Studio Lighting. Imagine you're in a dimly lit room. Meet uses AI to make it look like you're in a professional studio. How does that work? First, a pipeline of AI models analyzes the speaker, figuring out its shape and light reflection. Then, the browser uses your GPU to magically relight the speaker, like adding a virtual light. Now, Studio Look. This feature sharpens and reduces the noise of the speaker's face. A face detection model finds the face, and another model enhances it, making it clearer and reducing fuzziness. But the challenge here was that these AI features need to work in real time. That means the browser has to process a lot of video data and fast. JavaScript, while powerful, sometimes isn't enough for this kind of heavy lifting. That's where WebAssembly or WASM comes in. Google Meet uses a powerful C++ library called MediaPipe for its video processing. Normally, C++ code is for native applications. But now, with WASM, we can take that C++ code, compile it into a web-friendly binary format, and run it directly in the browser with near-native speed. This is crucial for real-time video processing. Essentially, WASM lets us tap into the full power of your computer CPU, which JavaScript alone can't always do. Thanks to WASM, Google Meet delivers amazing AI features across all major browsers, making us look great on camera. Without it, these real-time AI video enhancements wouldn't be possible on the web. Beyond Studio Lighting and Studio Look, Meet also uses a client-side background segmentation model and conducted an experiment comparing WebGPU and WebGL backends. Early results show up to 22% decrease in power consumption when using WebGPU on MacBook Air M2. This translates directly to a longer battery life and a smoother experience for users. On top of that, using a brand new web GPU feature called Subgroup Broadcast, Google Meet is allowing advanced features like background blur and replacement to run with significantly improved power efficiency. These web GPU powered features should be rolling out later this year. So far, we've looked at some amazing client-side examples. Now, let's look at how some companies implemented a hybrid approach. Tokopedia, an Indonesian technology company, is another great example that saw significant business impact from implementing client-side AI features. Mitra Tokopedia was one of their web applications which helped small business owners in more than 700 cities to sell digital products. A key step in Mitra Tokopedia's onboarding process required these sellers to verify their identity by uploading their national ID and a selfie with the ID. However, most sellers did not upload their photos correctly in the first step, causing the verification data to be rejected. This created thousands of tickets per week to the operations team for manual verification. Tokopedia was keen to solve this problem using ML. One of their key considerations was fast download and runtime performance for quick feedback to users and to cater to a variety of devices. They used MediaPipe and TensorFlow's face detection library, a package that provides models for running real-time face detection. Specifically, the TensorFlow.js runtime was used. The model returns a list of faces detected. The result contains a bounding box of each detected face, as well as an array of 6 key points for the detected face. This includes features such as the eyes, nose, and mouth. By adding this model at the very first step of the onboarding process, they were able to detect the seller's face clearly. Upon successful verification by the model, the relevant seller information was passed to the backend. If the verification failed, the seller was given a failure message and an option to retry. It's worth noting that they implemented a hybrid approach, where the face detection model ran client-side if the device could support it. Otherwise, it was run on the server. This allowed them to achieve fast feedback to users while catering to older or low-end devices. As a result of this implementation, the rejection rate significantly improved. To be more specific, the number of manual approvals decreased by almost 70%, and the onboarding rejection rate decreased by over 20%. This not only created a smoother experience for sellers, but also reduced the operational cost for the Tokopedia team. Policy Bazaar is one of the leading insurance platforms in India, with 97 million registered customers. They noticed that a significant number of users were coming onto their platform in the evenings, after the customer support team's working hours, and wanted to provide better service to those users. To achieve this, Policy Bazaar built a text and voice powered insurance assistance chatbot called Finova AI that combines multiple AI models using a hybrid architecture, where some parts of the solution run client side and some on the server side. Here's how their solution works. The user input goes through the built in language detector API. And if it's an Indic language, it gets converted to English using the built in translator API. To learn more about these built in APIs, refer to the talk mentioned on this slide. The translated query is then passed to a server-side model trained on Policy Bazaar's data and returns an English response to the user's question. The translator API then converts the text back into the user's native language if required. Policy Bazaar's example shows us that you don't need to choose between client-side and server-side models. You can combine or chain multiple models by catering each model to a specific task in the overall flow. Where low latency, cost, and privacy was required, a client-side solution was used. Where more complex models trained on custom data was needed, a server-side solution was used. At the end of this customer conversation, a transcription is forwarded to the human support staff for follow-up. However, what happens if a user decides to provide inappropriate or aggressive input to the chatbot? To tackle this, they used a toxicity detection model that runs fully client-side and powered by web GPU. Why client-side toxicity detection? Due to privacy and sensitivity reasons, they wanted to analyze messages on the device and only send meaningful data to the server. And eventually, when the conversation is sent to human agents for follow ups, they wanted to avoid toxic language. This was the motivation to implement a client side solution. Let's see this in action. When the toxicity detection model identifies a toxic message, the user is prompted to rephrase the message. The message is not sent to the server. An added benefit was that when they switched from WebGL to WebGPU backend for supported browsers, the model ran 10 times faster, which meant faster feedback to the user to revise their message. So far, we've seen how AI is making a real difference in the web experiences we use every day. Now, let's pull back the curtain and explore the technologies that made these features possible. Over to you, Yuriko.
All right, let's dive in. For the past few years, Chrome has been building primitives like WebGPU and WASM that allows AI to run on the web. As a developer, though, you'll probably interact with AI via handy libraries like MediaPipe and Transformers.js. These libraries abstract away the complexities, allowing you to focus on building amazing AI features for your websites. Let's briefly walk through how you can utilize these libraries in your websites. If you're interested in creating similar features like Bilibili, then you can use MediaPipe's image segmenter tasks. This task uses WebAssembly to let you segment images into regions based on the predefined categories. This allows for the identification of specific objects or textures, such as a person, a background, or a cat. Also, did you know that MediaPipe lets you run large language models completely on the browser, thanks to WebGPU? The LLMs that run on the browsers are typically smaller and less capable than the server-side LLMs, but they're good for scope tasks such as generating small text, retrieving information in natural language form, or summarizing documents. You also have Transformers.js, a library closely associated with the growing Hugging Face ecosystem that lets you use many of the ready-made AI models on the website for different tasks, including segmentation tasks, classification tasks, speech recognitions, and more. The addition of WebGPU support in Transformers.js version 3 last year has generated excitement and creativity amongst the developers. Here are the snippets of example that would not have been possible without the support of WebGPU. We've seen developers experimenting with reasoning models like DeepSeek optimized for in-browser inference entirely on Chrome. On top of that, Kokoro, an open-weight text-to-speech model with 82 million parameters, can now be used to convert text to natural-sounding speech and runs in-browser thanks to Transformers.js. It's 100% free and supports unlimited generations. Running a multimodal vision language model called Janus Pro 1 billion, was also made possible on the web, meaning you can create high quality images from text descriptions and engage in detailed image discussion, for instance. Developers' enthusiasm and creativities are just incredible. Since Chrome has been at the forefront of AI technologies, WebGPU is well supported in Chrome browser. It is also available in Safari Tech Preview and Firefox Nightly as we're recording. Luckily for us, WebAssembly's broad support across browsers positions the web as a platform ready for AI development, accessible to all users. I hope that gave you a glimpse into the technologies available to you today. Let me hand it back to Swetha to wrap it up.
So far, we've looked at strategies, real world examples, and the underlying technologies for you to build AI on the web. If you want to learn more, check out the link on the slide. I hope this talk inspired you to think of what you can develop for your own web app. We can't wait to see what you'll build. Thank you.